Noam, welcome to No Priors.
Hey, Elad. Thanks for having me on. Hi, Sarah.
Good to see you.
Yeah, thanks for joining. So you've been working on NLP and AI for a long time. So I think you were at Google for something like 17 years off and on. And I think even your Google interview question was something around spell checking, an approach that eventually got implemented there. And when I joined Google, one of the main systems being used at the time for ads targeting was like Fill and Fill clusters and all this stuff, which I think you wrote with George Herrick. And so it'd just be great to get kind of your history in terms of working on AI, NLP, language models, how this all evolved, what you got started on, and what sparked your interest.
Oh, thanks, Elad. Yeah, just always was naturally drawn to AI, wanted to make the computer do something smart. Seems like pretty much the most fun game around. Was lucky to find Google early on, and it really is an AI company. So got involved in a lot of the early projects there that maybe you wouldn't call AI now, but seemed pretty smart at the time. And then more recently was on the Google Brain team starting in 2012. It looked like a really smart group of people doing something interesting. I had never done deep learning before, or neural networks, I guess, as it was called then, or whatever. I forget when the rebrand happened, but it turned out to be really fun.
That's cool. And then, you were one of the main people working on the Transformer paper and design in 2017. And then you worked on Mesh TensorFlow, I think, sometime within the following year. Could you talk a little bit about how all that got going?
Yeah, I messed around a few years on the Google Brain team and utterly failed at a bunch of stuff till I kind of got the hang of it. Really, the key insight is that what makes deep learning work is that it is really well suited to modern hardware, where you have the current generation of chips that are great at matrix multiplies and other forms of things that require large amounts of computation relative to communication. So basically, deep learning really took off because it runs thousands of times faster than anything else. And as soon as I got the hang of that, started designing things that actually were smart and ran fast. But the most exciting problem out there is language modeling. It's just it's the best problem ever, because there's an infinite amount of data. Just scrape the web and you've got all the training data you could ever hope for. And the problem is super simple to define. It's just predict the next word. The fat cat sat on the, okay, well, what comes next? It's extremely easy to define. And if you can do a great job of it, then you get everything that you're seeing right now and more. You can just talk to the thing, and it's really AI complete. And so got started around 2015 or so. Working on language modeling and messing with the recurrent neural networks, which was what was great then. And then Transformer kind of came about as someone had the bright idea. It was Jakob was great that hey, these RNNs are just annoying. Let's try to replace them with something better. In attention, and overheard a couple of colleagues talking about it, and in the next cube over, I was like, that sounds great. Let me help you guys. These RNNs are annoying, and we could. It's going to be so much more fun.
Can you quickly describe sort of the difference between an RNN and a transformer-based or attention-based model?
Yeah, sure. Okay, so the recurrent neural network is the sequential computation where every word, you read the next word and you kind of compute your current state of your brain based on the old state of your brain and the and what this next word is, and then you predict the next word. So you have this very long sequence of computations that has to be executed in order. So that, the magic of Transformer, kind of like convolutions, is that you get to process the whole sequence at once. I mean, it still talks, it's still a function of the the predictions for the later words are dependent on what the earlier words are, but it happens in like a constant number of steps where you get to take advantage of like this parallelism of you can look at like the whole thing at once, and like that's what modern hardware is good at, is parallelism. And now you can use the length of the sequence as your parallelism, and everything works super well. Attention itself, it's kind of like you're creating this big like key value associative memory where you're like building this big table like with one entry for every word in the sequence, and then you're kind of looking things up in that table, and it's all like fuzzy and differentiable, and a big differentiable function that you can backprop through. And people had been using this for problems where there are two sequences, where you've got like machine translation, you're like translating like English to French, and so while you're producing the French sequence, you are like looking over the English sequence and trying to pay attention to the right place in that sequence. But like the insight here was, hey, you can use the same attention thing to like look back at the past of the sequence that you're trying to produce. And the beauty is that that it runs great on GPUs and TPUs, and it's kind of parallel to like how deep learning is has taken off, because it's like great on the hardware that exists, and this sort of brought the same thing to sequences.
Mm-hmm. Yeah, I think the classic example to help people picture it is like, saying the same sentence in French and English, like the ordering of the words is different. So you're not mapping like one to one in that sequence. And to figure out how to do that with parallel computation without information loss is like a really elegant thing.
Yep.
Yeah, it seems like the technology has also been applied in a variety of different areas. The obvious ones are these multimodal language models. So it's things like ChatGPT or what you're doing a character. I've also been surprised by some of the applications into things like AlphaFold, the protein folding efforts that Google did, where it actually worked in an enormously performant way. Are there any application areas that you found really unexpected relative to how transformers work and relative to what they can do?
I've just had my head down in language. Yeah. Like here you have like something that like a problem that like can do like anything. Like I want this thing to be good enough, so I just ask it like, how do you cure cancer, and it like invents a solution. And like so I've been totally ignoring like what everybody's been doing in all these other modalities, where like I think a lot of the early successes in deep learning have been like in images, and people are like all excited about images, and I kind of like completely ignored it, because like an image is worth 1,000 words, but it's like 1,000,000 pixels, so like the text is like 1,000 times as dense. So like kind of big text nerd here, but it's very exciting to see it take off in in all these other modalities as well. And those things are going to be great. It's like super useful for building products that people want to use, but I think that a lot of the core intelligence is going to come from these text models.
What do you think creates the asymptote that all this is being built against? Because people often talk about just scale, like you just throw more compute and this thing will scale further. There's data and different types of data that may or may not be available. There's algorithmic tweaks. There's adding new things like memory or loopbacks or things like that. Like what do you think are the big things that people still need to build against, and where do you think this sort of taps out as an architecture?
Yeah, I don't know that it taps out. I mean, we haven't seen it tap out yet. The amount of work that has gone into it is probably nothing compared to like the amount of work that will go into it. So quite possibly there will be all kinds of like factors of 2 inefficiency that people are going to get through better training algorithms, better model architectures, better ways of building chips and using quantization and like all of that. And then there are going to be, factors of 10 and 100 and 1,000 of just like, scaling and money that people are just going to throw into the thing because, hey, like everyone just realized this thing is phenomenally valuable. So, and at the same time, like, I don't think anyone's seen a wall in terms of how good the stuff is. So I think it's just going to keep getting better. And I don't know what stops it.
What do you think about this sort of idea that we can increase compute, but the largest models are undertrained. We've used all the text data on the internet that's easily accessible. Like, we have to go improve the quality. We have to go do human feedback. Like, how do you think about that?
Yeah, I mean, in terms of getting some more data, like there are a lot of people talking all the time. I mean, there's, why do you
think we do this podcast?
Right, like there's like 10 billion people, like producing like 1,000, like I don't know, 10,000 words a day. I mean, that's like a lot of words that and pretty soon many of those people will be doing a lot of that talking to AI systems. So I have a feeling like a lot of data is going to find its way into some AI systems. But I mean, in privacy preserving ways, I would hope. And then the data requirements tend to go up like with the square root of the amount of computation, because you're going to train a bigger model and then you're going to throw more data at it. So I think I'm not that worried about coming up with data, and I feel like we could probably like just generate some more with the AI. Like,
yeah. And then what do you think are the main things to solve for these models going forward? Is it hallucinations? Is it memory? Is it something else?
I don't know. I kind of like hallucinations.
It's also a feature.
They're fun. Yeah. We'll call it a feature. I mean, some of the things we want to work on the most are like memory, because our users definitely want their virtual friends to remember them. There's there's so much you can do with personalization, and you want to dump in a lot of data and use it efficiently. I think there's like a ton of great work going on in trying to figure out what's real and what's hallucinated. Of course, I think we'll solve those.
Do you want to talk a little bit about Lambda and your role with it, and how that led eventually to Character?
Yeah, sure. Yeah, I guess. My co-founder Daniel de Freitas, he's like the scrappiest, most hardworking, really smartest guy. He's kind of been on this lifelong mission to build chatbots. Like since he was like a kid in Brazil, he's like always been trying to build chatbots. So like he came to join us at Google Brain because I think he had read some papers and figured that this neural language model technology would be like something that could actually generalize and and build something truly open domain. So and like he did not get a lot of headcount. Like he started the thing as like a 20% project where like people are encouraged to spend 20% of their time like doing whatever they want. So and then he just like recruited like an army of like 20% helpers who were like ignoring their day jobs and like actually just helping him with the system. And he like went as far as like going around and like panhandling people's TPU quota, and he called this project Mina because I guess it came to him in a dream, and like at some point I'm like looking at the scoreboard and it's like, what is this thing called Mina and why does it have 30 TPU credits? And it was like Daniel had like just gotten a bunch of people to contribute, and then he was like really successful at this because in building something really cool that actually worked, where like a lot of other systems were just like totally failing, either because people were not just weren't scrappy enough, or were like going for like rule-based systems that were just never going to generalize. So like at some point I was like, okay, there's so many ways we can make this technology better by like factors of 2, but like the biggest thing is like just convince everyone that this is like worth trillions of dollars by like demonstrating some application that is clearly super valuable to like billions of people. So,
and Lambda was this, I believe, is the internal chatbot pre-GPT at Google that was famously in the news because an engineer thought it'd become sentient, right?
Yeah. So that was like a renaming of Mina. So I guess I went and helped Daniel on Mina. We got it on some giant language models, and then kind of became like an internal like viral sensation, and then got renamed to Lambda. And we had left before that before the business about somebody thought it was sentient. I'm flattered.
Can you talk a little bit about just what why it wasn't released? Like what some of the concerns were?
I mean, I think just like large companies have concerns around like launching products that can say anything. Like, I mean, it's probably just a matter I would guess it's just like a matter of how much you're risking versus how much you have to gain from it. So figured, hey, startup seems like the right idea, and that you can kind of just move faster.
Yeah. So tell us about Character. Like, what's the origin story there? Did you and Daniel look at each other one day and were just like, we have to get it out there?
Yeah, pretty much. We're like, yeah, and kind of noticed, hey, there are people who like just go out and get some investors and start doing something. So we're just like, okay, now we let's just build this thing and launch it as fast as we can. So hired like a total rock star team of engineer researchers and got some compute.
Have one thing that comes up a lot is people say that you all have, one of the truly extraordinary teams in the AI world. Are there specific things that you recruited against, or how did you actually go about finding these people?
Some people we knew from Google happened to get introduced to Maialat formerly from Meta, who's had built a lot of their large language model stuff and their sort of neural language model infrastructure, and he. A bunch of other Meta people followed him, and they were great.
Is there anything specific that you would like look for in people, or ways to test for it, or was it just standard interviewing approaches?
I mean, a lot of it was just kind of motivation. I think Daniel tends to very, very highly value like motivation. I think he's looking for something between like burning desire and childhood dream. So like there were a lot of great people that we did not hire because they didn't quite meet that bar. But then we got a bunch of people who were kind of up for joining a startup and really talented and highly motivated.
I mean, speaking of like childhood dreams, like, so do you want to describe the product a little bit? Like, you have these bots, like, they can be user created, they can be character created, you can be public figures, fictional figures, anybody with like a corpus that you can make up, or historic figures. Like, how'd you even arrive there as like the right form for this?
Yeah, I mean, like, basically, this is kind of a technology that that's so accessible that like billions of people can just invent use cases, and you, like, it's so flexible that, you really just want to put the user in control, because often they know way better than you do what they want to use the thing for. And I guess we had kind of seen, some of the, assistants from sort of assistant bots from from large companies. You've got Siri and Alexa and Google Assistant, and like, some of the problems there are that, like, when you're just projecting one persona to the world, like, people will expect you to like be very consistent in, say, like, your likes and dislikes, and B, just like not be offensive to anyone, and like not really have an opinion. It's kind of like, like you're the Queen of England and you can't like say something that's going to disappoint someone, or like, I don't know, like, I remember, like, I think it was like George H.W. Bush said he didn't like broccoli, and then like the broccoli farmers were like all mad at him or something. So like, you can't if you're like such a public, trying to present like one public persona that everyone likes, you're going to end up just being boring, essentially. And people just don't want boring. People want like want to interact with something that feels human. So basically, you need to go for like multiple personas. Like, let people invent personas as much as they want. And kind of, I like the name character because it's like, okay, it's got a few different meanings. Use character like, ASCII character, it's like unit of text, character like, like a persona, or character like, good morals. But anyway, so I think that's just how people like to relate to this stuff. It's like, okay, I kind of know what to expect, like, from an experience, if I can kind of define it as a person or a character, maybe it's someone I know, maybe it's just like something I invent. But it kind of helps people like kind of use their imagination.
So what do people want? Like, do they do like their friends? Do they do fiction? Do they do entirely new things?
Yeah, I mean, there's like a lot of there's a lot of role playing games are big, like text adventure where it's just like making it up as it goes. There's a lot of like video game characters in anime, and there's some amount of people talking to public figures and influencers, and I think a lot of people have these existing parasocial relationships where they've got characters they're following like on TV or or internet or influencers or whatever, and so far they just have not had the experience of now this character responds, because it's always something you can watch, or maybe you're in like a 1,000-on-1 like fan chat or something where like this VTuber will like write back to you like once in an hour or something. But like now they get the experience of I can just create a version of this privately and just like talk to it, and it's pretty fun. We also see like a lot of people using it because they're lonely or troubled and need someone to talk to. Like, so many people just don't have someone to talk to. So and a lot of use kind of crosses all of these boundaries. Like somebody will post, this video game character is my new therapist or something. So it's a huge mix of like fun and people who need a friend and like connecting with game playing, all kinds of stuff.
How do you think about emotion, like both ways, right? Like people's relationships with characters, or like how, like what level we are at in expressing coherent emotion and how important that is?
Oh, yeah. I mean, probably you don't need that high end like level of intelligence, like to do emotion. I mean, emotion is great and is super important, but like a dog probably does emotion pretty well, right? Like it's like, I mean, I don't have a dog, but I've heard that like a dog is great for like emotional support, and it's like got pretty lousy linguistic capabilities, but the emotional use case is huge, and people are using the stuff for all kinds of emotional support or relationships or whatever, which is just terrific.
How do you think the behavior of the system will change as you kind of scale things up? Because, I think the original model was trained on not a ton of money. Like on a relative basis, you folks were incredibly frugal.
I think, we should be able to make it smarter in all kinds of ways, both algorithmically and just scaling. Get more compute and train a bigger model and train it for longer. It should just get more brilliant and more knowledgeable and better attuned to like what people want, what people are looking for.
You have some users that are on the service like many hours a day. Like, how do you think about your target user over time, and like, what the usage patterns you expect to be are?
We're going to just leave that up to the user. Like, our aim has always been like get something out there and let users decide, what they think it's good for. And we see like, somebody who's on the site today is active for about 2 hours on average today. That's of people who send a message today, which is pretty.
That's wild.
That's pretty wild. But like,
it's amazing.
It's definitely, it's a great metric, like that people are finding some sort of value in it. And as I said, it's really hard to pin down exactly what that value is, but because it's really like, a big mix of things. But like our goal is like make this thing more useful to people and let people kind of customize it and decide what they want to use it for. If it's brainstorming or help or information or fun or like emotional support, like let's just get it into users' hands and see what happens.
How do you think about commercialization?
Oh, we're just going to lose money on every user and make it up in volume.
Oh, good. Good
No, I'm
strategy.
joking. No,
the traditional 1990s business model. So that's good.
No,
It's kind of a 2022 business model too.
You should issue a token and then just make it a crypto thing.
No. We're going to monetize at some point pretty soon because again, this is the kind of thing that benefits from having a lot of compute, and rather than just burn investor money, the most scalable way to fund something is actually provide a lot of value to a huge number of people. So probably try some premium subscription type of service where we can as we develop some new capabilities that might be a little more expensive to serve, then start charging for them. I really like that anyone can use it now for free because it's there's so many people that it's providing so much value.
I mean, it's really taken off as a consumer service in a really striking way. If you look at the numbers of users and the usage per hour, the number of hours of usage per user, which is insane. Are there any scenarios where you think it's likely to go down like a commercial setting where you have like customer service bots who provide like a brand identity around support, or is that just not that interesting right now as a direction?
I mean, it's right now we have 22 employees, so we need to prioritize. We are hiring, so definitely enough work for way more people. Priority number one is just get it available to the general public. Definitely it would be fun to launch it as customer service bots when we're able. People would just stay on customer service all day.
You're like chatting with a friend effectively. So let's start with the customer support, and that actually happened apparently on some old e-commerce sites like eBay. Apparently was effectively a social network really early on as people were buying and selling things and just kind of hanging out because there weren't that many places to hang out online. So I always think it's kind of interesting to see these emergent social behaviors on different types of almost like commercial products or sites. But it makes a lot of sense.
So you said one of the obvious reasons Lambda didn't ship immediately at Google was safety. How do you guys think about that? Remember, everything characters say is made up.
Exactly. Right. Just make sure the users are aware that this is fiction. If there's anything factual that you're trying to extract from it at this point, it's best to go look it up somewhere that you find reliable. There are other things, types of filters we've got there. We don't want to encourage people to harm, hurt themselves or hurt other people, or we're blocking porn. There's been a bit of protest around that, but
yeah. And do you view all this as a path to AGI or sort of super intelligence?
Sure. Yeah.
And is that part of the goal? For some companies, it seems like it's part of the goal. And for some companies, it seems like it's either not, it's explicitly an anti-goal, or if it happens, it happens. And, the thing people are trying to build is just something useful for people.
What a flex. AGI is a side effect.
Yeah. Well, that was a lot of the motivations here. Because, my main motivation for working on AI, other than that it's fun, fun is secondary. The real thing is I want to drive technology forward. There are just so many technological problems in the world that could be solved. For example, all of medicine. There are all these people who die from all kinds of things that we could come up with technological solutions for. I would like that to happen as soon as possible, which is why I've been working on AI, because rather than working on, say, medicine directly, let's work on AI, and then AI can be used to to accelerate some of these other things. So basically that's why I'm working so hard on the AI stuff. So I wanted to have a company that was both AGI first and product first, because product is great. It lets you build a company and motivates you. And so the way you have a company that's both AGI first and product first is that you make the make your product depend entirely on the quality of the AI. Like the biggest determining factor in the quality of our product is how smart the thing's going to be. So now we're like fully motivated to make the AI better, and and to make the product better.
Yeah, it's a really nice sort of virtuous feedback loop, because to your point, as you make the product better, more people interact with it, and that helps make it a better product over time. So it's a really smart approach. How far away do you think we are from AIs that are as smart or smarter than people? And obviously they're smarter than people on certain dimensions already. But I'm just thinking of something that would be sort of equivalent.
Yeah, I guess we just always get surprised at like what dimensions the AI gets better than people. Pretty cool that some of these things can now like do your homework for you. I wish I had that as a kid.
What advice would you give to people starting companies now who come from backgrounds similar to yours? Like, what are things that you learned as a founder that you didn't necessarily learn while working at Google or other places?
Oh, good question. Basically, like you learn from like horrible mistakes, but like I don't feel like we've made really, really bad ones so far, or at least we've kind of like recovered. But I guess just like build the thing you want really fast, and like hire people who are just like really motivated, to do it.
So one quick question just for users, like what's the secret to making a good character? Like if I'm going to go make a copy of Elad instead of rubber ducking with myself, like what do I need? Just like my text chat with Elad?
Oh.
Yeah, stop disappearing the chat, Elad.
I'm just trying to protect myself from becoming a character, so.
Yeah, I mean, so you can do it just as simply as like put in a name and a greeting is all you need typically for for famous famous characters, or famous people, because the model probably already knows what they're supposed to be like. If it's something that the model is not going to know about because it's a little less famous, then you can create an example conversation to show it what how the character is supposed to act.
It's insane that character is only 22 people. Like you're hiring, what are you hiring for? What are you looking for?
So far, 21 of the 22 are engineers. So we're going to hire more engineers. No, I'm joking. We are going to hire more engineers.
Shocked.
Both in the deep learning, but also front and back end. Definitely hire more people on like the business and product side. We've got a recruiter starting on Monday.
Hard requirement, burning desire or childhood dream to bring characters to life.
Yeah, an exceptional person. Yeah.
Yep.
And then do you mind if I ask you like 2 or 3 quick fire questions and then we'll wrap up?
Sure.
Okay. Who's your favorite mathematician or computer scientist?
They were all standing on the shoulders of giants. So it's hard to pick out in this big tower of mathematicians and computer scientists. I got to work with Jeff Dean a lot at Google. He's really nice. Fun to work with. I guess he's now running their large language model stuff. So a little bit of a regret of having left Google, but hope we collaborate in the future.
Yeah. Do you think math is invented or discovered?
Oh, that's interesting. Okay, I guess discovered. Maybe all of it's discovered. We're just discovering it.
And then last question: what do you think is something you wish you'd had invented?
Let's see.
Teleportation.
Ooh, that
seems hard.
Sounds like a good one. I'm not going to step into
some
a
physics
teleporter.
Involved here.
Yeah, I do not want to be like the disassembled or anything. Like no beaming. I'll walk. Like I don't want like my brain
elevator, we need to teleport.
upload into a computer. Like I think I would like to keep my physical body, please. Thank you.
Oh, I don't care. Let me out of the meat box. What do you wish you'd invented?
Oh, what we wish we'd invented. Sorry, I was dodging the question.
Almost.
Just focused on inventing AI that that can push the technology forward.
Such a good founder answer.
Makes sense. Very focused. It's great. Well, Noam, this was an incredible conversation. Thank you so much for joining us today on the podcast. Yeah.
Thank you, Elad. Yeah. Thank you, Sarah.
Yeah, good to see you. Thanks, Noam.